All right, guys, this is video number 5 of the series. We're going to introduce you to a move function. So, if you remember, a quick review. First video, we set up the card. We set up the chassis with all the cards that are in it. Second one, we created tags, and they were all bools. Third one, we created a program. And in video number 4, we actually showed you how to download, run the program, and monitor it. Now we are going to add a move function. It's one of the most common functions out there, including timers, counters, copies, fills. So we're going to add a move function. So we're going to add a line of logic, a rung. We can get that right up here. All right. Now, in order to do this, I think we're going to go ahead and do 2. So just to make it simple, I'm going to copy this instruction and paste it. Oh, right there. All right. And then I'm just going to go up here and I'm going to grab a move function. This one right here. All you got to do is bring it down, put it on there. Now, we're going to go ahead and add another rung. This time we're going to copy this one. And we're going to see that this depending on which one is on, we're going to get 2 different results into this. Now, this move instruction needs to be used with a dent. And we have not made a dent instruction yet. Tag, I'm sorry. So we go up here. We're going to create a new tag. We are going to call this one just the letter A. Actually, I'm going to call it A integer. Now, an integer is just a file or a register, a place to put information. It's like a big storage area. This is going to be a base. And we're going to make it a dent. A dent is a double integer. That's 2 words of information. So I am going to create that. All right. Now we're going to go over to this, and you'll see that our rungs are red because we do not have enough information in here for them to be correct. So I'm going to just move a value into my A integer. And you'll see we got a blue rung. That means we're good. And what this is going to do is when this one comes on, which is the one with the green light, or up here, it's going to move at a value, a decimal value of 11 into this integer. Now this one right here, I'm going to make this one move a different number into it, a different value. Let's go with 6. And that is going to move it into a integer, right? Okay, so all I need to do now is download this, but we're going to look at the tags real quick. Here's A integer. It will not have a value in here because we haven't downloaded it. It is built. Now, if you remember, when you're doing this, this is a dent. So it's 32 bits. So after this, we'll add something here. If A0 is on, becomes a 1, it will turn something else on. All right. You remember how to do number conversions. That's all this is really doing, is a number conversion, converting it from a decimal value to a binary value, and we're getting a result. So I'm going to go up here. I'm going to do a who active. I'm going to download. All right, here we go. So you'll see that this is showing this move will move an 11 into the A integer, but the current value is 6 because this move moved a 6 into A integer. That's the current value. All right. And if we go to our tags, our A integer is right here. We go to monitor tags. You'll see the value of 6 right here. Now, remember the value of 6. Each one of our bit locations hold a value starting at 0. 0 has the value of 1. 1 has the value of 2. 2 has the value of 4. 3 has the value of 8, and it doubles. You remember that from the number conversions? So if we look at this, the 0 is not on. The 1 is on, it holds the value of 2. The 2 is on, it holds the value of 4. Right? And so on and so forth, because it keeps doubling. Now, you can see it right here. 0, 1, 2, 3, 4, 5, 6, 7. Then 8 through 15. Remember this from the number conversions. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8192, 16,384, 32,768, and I don't remember them all. Past that, I would have to get a calculator out. That's only the ones that I have memorized. It is if we want to change it, this is the decimal value. If we want to see the binary value, we can see it right here. All right. It's harder for us to read in binary, so let's just look at the decimal value. All right. So let's go back to the program. And if I press the start button, the latch will come on. It will hold itself on. This latch will come on, turning on the green light. This one will go off. We will lose the red light. This one will come on, moving the value of 11 into A integer. And this one will go off, so we will no longer move the 6. Okay, so I'm going to press the start button. And if we go to our tags, you can see right here, it moved the value of 11 into this because this one is on. This one right here is not on. And if I hit the stop, you'll see that it should change back to a 6. And let's go to the tags and watch it there. All right. Monitor tags. If I hit the start button, you'll see that it changed to an 11 because we moved the value of 11 in there. And if I hit the stop, it moves it back to a 6. Now let's go back to the program real quick. How could we use something like this? Well, let me go offline, and I'm going to add one more rung of logic. And you remember, if in an even number in decimal, then the 1 will not be on in the position of a 0. And that's why I used an even and an odd number. So let's add a bit, and you can do this a couple different ways. You can come here, a dot 0, a integer dot 0 comes on, then we're going to turn on another light, or this could turn on a motor. We're going to go up here, we're going to create a new tag, and we're going to call this yellow light. It is a base, and remember, this one needs to be a bool because it's just 1. Create. There it is right there. If we go back to our main routine, and I make this yellow light. All right. Now this is getting, before we were using this internal bit, this latch, this is getting this directly from the value in this register, or this integer. And it's A0 is what it is. We don't have to have the word integer in there. I just wanted to make sure that everybody knew what that was. Our A integer, position 0, will turn on this yellow light. All right, if I go up here to who active, processor in slot 0, I'm going to download. All right, here we go. So this, again, this one is going to only get this when the value of A.0, A.0, this one right here, turns to a 1. This position right here. So when I hit the start button, you'll see that it came on. Remember, this one has the value of 8, 2, and 1, adds up to 11. Let's go to the program. And there it is. All right. And if I turn this off, A.0 will go off because it will move a 6 in there. When we move a 6 in there, only the position of 1 and 2, which hold the value of 4 and 2, will come on. So if I hit the stop, it will go off, and we lose that integer value. Let's go ahead and go to the tags real quick. Monitor tags. See, the value is 6. A.0 is off. A.1 is on. A.2 is on. And if I hit the start, A.0 just came on, which turned on the yellow light. And we should be able to see that right down here. All right, that is how a move function works. If you have any questions on a move function, remember the help section right up here will help you find different things. It is very informative. There's your move functions. It'll be in these lists right down here. All you got to do is go through and find the right one. But tons of information on here. All right, guys, that concludes video number 5. Our next one will probably be a timer counter, a copy, a fill, another type of a function. We'll keep going through these videos. We'll keep making them. We'll add something to it each time so that you guys understand everything that we're doing in the class. All right, thanks, guys.